Okay, so what is a chi-square test and why would we use it? So a chi-square test is a statistical test used to compare observed results with expected results. So the purpose of doing this is to determine if a difference between observed data and the data you would expect due to chance. So why would we use it? We would use the chi-square goodness of fit test whenever we want to know if some categorical variable follows a hypothesized. So for example, in Mendel's law of independent assortment, it states that genes do not influence each other with regard to how the alleles are sorted into gametes. So every possible combination for every gene is equally likely to occur. If we drew a punnett square for these alleles for the F2 generation, it would give us 16 equally likely combinations. So from these we could infer a ratio of 9 to 3 to 3 to 1. So these are the offspring ratios we would expect, assuming a large enough sample size. So to say it a bit differently, the null hypothesis for our test is that there will be no influence, and the 9 to 3 to 3 to 1 ratio will definitely occur. So let's say we did this and obtained the following results, which you can see in the observed column. Okay, so how would we actually calculate the chi-squared value using this equation? So for observed expected, we just take the difference, which is minus 5, Okay, so to obtain our chi-squared value, we simply need to add up all of these values here. Okay, so the next step would be to decide how many degrees of freedom we have. As we have 4 rows, degrees of freedom would be 3. So looking at the 0.05 column, we see the critical value 7.815. This means that the null hypothesis cannot be rejected, as 4.71 is less than 7.82. So looking at our chi-squared value of 4.711, we can see it corresponds to an area of the table associated with a probability that is higher than 0.05 or 5%. So remember that the values to the left of a critical value p are those corresponding to higher probabilities, so something is more likely to occur. So if our value was, say, 10 plus, 12, 16, whatever, we could conclude the data is not a good fit for our hypothesized distribution / law of independent assortment.